Hello everyone, welcome to my channel on YouTube. These videos I keep posting on a different kind of math, mental math, Vedic, strategic math. Look at the questions, do it quickly without paper pen.
Today, we will continue with the part 2 of the exponents, the laws of the exponents. How different exponents work, what are the laws, and how do we simplify. I have on the screen my written notes. The first law of the exponent says when we have the common base, and we have different exponential powers, and we multiply those two numbers. Again, I repeat, when we multiply two numbers, three numbers, but base is same and the exponential power is different, then the base is taken as only once and the power gets added up. Like I have shown in the example, a raised to the power of n times a raised to the power of m. So what will happen? My common base is a. What will happen to the power? M plus n. Now I have given the example also, but let's take another example. I have written 2 raised to the power of 2 times 2 raised to the power of 4. So what will happen? What is my base here? My base is 2. That's the common base. So I will write it as 2. What will happen to the exponential power 2 and 4 here? In the bracket 2 plus 4, which becomes 2 raised to the power of 6. And if the question says us to simplify, find the value of it. So what shall be the value? You can simplify, you can write 2 times 2 times 2. Repeat it till 6 times. What shall be the value? Easy way, make pairs 4, 4, 4. 4 times 4, 16. 16 times 4 is 64. So here my answer is 64. I have written another example on the board. 3 raised to the power of 3 multiplied by 3 raised to the power of 4. So how are we going to simplify? 3 as a common base. Write 3. Now, what shall be the power? 3 plus 4. And I can rewrite this as 3 raised to the power of 7. Always try to put the base in the brackets and power outside that so that we don't get confused. Sometimes when we are rushing in the competition or even in the examination, we mess up on the base and the power. So please keep brackets and base and number power separated. So here 3 raised to the power of 7. I can write this as 3. I am just showing it to you. Gradually, I will be sharing the link where you can actually memorize some of the perfects, cubes, squares, fifth powers and all that, and so that we don't have to waste time. We can just do the calculations quickly. But here I am showing you how you can fasten up your process, how you can speed up. Now write it like this. This becomes 9. 9, 9. 9 times 9 is 81. 81 times 9 is 729. We should know what is 3 raised to the power of 6 is, because that's a very common numbers used in the examinations. Now 729 times 3 is nothing but 2187. And your final answer is 2187. Here is your second rule or the law for solving the exponent. When I have two numbers to be divided and their base is same, they have a common base, what will happen to the exponential powers? We subtract the denominator's power from the numerator's power. I'll take an example and I'll show you how it works. I have written when two exponents with the same base are divided, their power gets subtracted but the base remains the same. And I have shown you the law in the standardized form. A raised to the power of m divided by a raised to the power of n is equal to a m minus n. Now let's take example. I have written 3 raised to the power of 8 divided by 3 raised to the power of 2. Now, for the ease of calculation, I can write 3 raised to the power of 8 divided by 3 raised to the power of 2. Now, this can be rewritten as 3, 8 minus 2. Or I can write 3 raised to the power of 6, and 3 raised to the power of 6 is nothing but 729, and our answer is 729. Now this is the third law of the exponent. Any base or any exponent which has a negative power, how we simplify, it will become the fraction, or I can say it becomes the reciprocal of the given base. And reciprocal is nothing but the flip of the number, which means the numerator becomes denominator and the denominator will become numerator. Let's first understand what is reciprocal equal to. I have written on the board 4. Its reciprocal will be 1 upon 4, because I can write 4 is equal to 4 over 1. And by the definition of the reciprocal, I will make the numerator as denominator and denominator will become the numerator. That is what is the meaning of a reciprocal is. Suppose you have a given number as, let's say, I take another example. You have 2 over 3. If I have to find the reciprocal is equal to 3 over 2. Now I have written 2 examples on the board. 4 raised to the power of negative 3. Whenever we have the power as negative 3, that negative will make the number into the fraction, and the fraction is nothing but the reciprocal. How we write? We will write this as 1 upon 4 raised to the power of 3. Now 3 will not be rewritten as negative 3, it will always be written as a positive exponential power. Again, I'm repeating, please make sure when you convert the number into the fraction, the negative exponential power will be converted into the positive number. The number or its value will remain the same, but instead of negative, it will be positive. So you can simplify this as 1 upon 4 times 1 upon 4 times 1 upon 4, which is equal to 1 upon 64. And that's my answer. I have written example as 2 by 5 raised to the power of negative 2. Now here I'm telling you directly we learned we can flip it into the reciprocal, but as I said it becomes into a fraction. So how we write this as 1 over 2 by 5 raised to the power of 2. Now when we simplify this, I'll be giving you one session on simplifying the fractions, especially the division of the fractions. But for now, when we see it's 1 divided by 2 over 5 raised to the power of 2, it actually becomes 5 by 2, and this whole is raised to the power of 2. Let's simplify this. We get 5 over 2 times 5 over 2, which is nothing, 25 by 4, or we can write it into the mixed numbers. It will be 6, 1 over 4, and that's my answer. Now this is the fourth law of solving the exponent. Any number, or I could say any exponent, when multiplied by some other number, or I can say that it is the number which is multiplied by some power basically. In the example I have shown a raised to the power of m multiplied, whole multiplied by some another number, or it is raised to some power. When exponent is raised to some power, the powers get multiplied. Simply. Let's take an example. I have an example on the board. 2 raised to the power of 3 whole raised to the power of 4. So basically an exponent is raised to the power of 4. So how do we simplify? We will write it as 2. What will happen to the powers? The powers will get multiplied, and we write it as 2 raised to the power of 12, and that's our answer. If the question says to simplify it further, we will simplify it. Otherwise, we will just leave the answer in this form. It depends upon the question what they ask you. The last law of the exponent is say any number raised to the power of 0 will always be 1. I will write the example. I can write 2 raised to the power of 0. Answer is 1. I can write 120,000 raised to the power of 0. My answer is 1. Any number raised to the power of 0 is 1. With this, we will finish the part 2 of the exponents, how we simplify. Gradually, when I cover these topics, I'll be taking up some problems from the real world, the real questions coming up in the various competitions, or even otherwise in the pre-algebra math, so that you can see. Sometimes we get confused how to simplify, how to reduce. So you will learn those things in the upcoming sessions.